Hello everyone, now we have to discuss the phasor diagrams, analysis of phasor diagrams in star and delta connection. At a time I am providing star as well as delta connections with respect to lagging, leading as well as UPF load, that is inductive load, capacitive load and pure resistive load. Okay, we will compare the phasor diagrams in star as well as delta with respect to lagging first, later UPF, then followed by capacitive load. Then only you will have better idea how to draw phasor diagrams, and that too here I am providing the simple trick to draw phasor diagrams. Okay, before that first we have to write some points. We all know that in case of star connection, what are the currents IR, IY and IB? Those are what? Obviously those are phase currents, right, which are equals to line currents. Clear? In case of delta, VRY, VYB and VBR, those are what? Phase voltages, which is equals to line voltage, right? Because the voltage between two nodes, which is equals to the voltage between two lines. Okay, no problem at all. Here the voltages are differ. In this case of delta, the currents are differ, right? That's why VR, Vy and Vb, those are what? Phase voltages, like that VRY, VYB and VBR are what? Like that. In this case of delta, IRY, IYB and IBR are what? IR, IY and IB. These are what? Phase voltages. These are what? Line voltages. These are what? Between R and Y, phase currents. These are what? Line current. That's it. Okay. So now we have to get the relation between line voltages and phase voltages. We all know that to get line voltage, which is nothing but what? Vector difference of two voltages, two phase voltages, right? VYB should be equals to what? VY minus VB. Like that VBR, which is equals to phase voltage of VB minus phase voltage of VR. That's it. Here also, to get line currents, IR, vector difference of what? Two phase currents, that is IRY minus IBR. Like that, to get IY, which is equals to IYB minus IRY. Clear? To get IB, we have IBR minus IYB. That's it. So in case of a star, phase current should be equals to line current. In case of delta, phase voltage should be equals to line voltage. But coming to voltage, in case of star, line voltage should be equals to root 3 times of phase voltage and line current should be equals to root 3 times of phase current in case of delta. Okay. Later we will summarize the conclusions. First we have to draw phasor diagrams with respect to different types of loads. Here I am providing first load, lagging load. Okay, with respect to lagging load, we have to analyze the first phasor diagram. Okay, that is inductive load, right? That is simply it is inductive load, that is series or parallel combination of RL load. Means what? Inductive load means what? common point, phase current lags phase voltage by phi. This is the common point for every connection. Lagging load means what? Phase current lags phase voltage by phi. That's it. Now here I am telling the important trick to draw phasor diagram. First you have to draw phase voltage. If you consider any phasor diagram, first you have to draw phase voltage. Later you have to check the load. Here the load is what? Lagging load. So always after drawing phase voltage you have to draw phase current. That's it. Phase current should be lags phase voltage by phi. Okay. Later we have to draw line voltage in case of star connection, then line current in case of delta connection. That's it. First you have to draw phase voltage. In case of star, phase voltage is what? VR. In case of delta, the phase voltage is what? VRY. If we have any confusion, just write here. This is what? Phase voltage. This is what? Phase voltage in delta. But in case of delta, phase voltage should be equals to line voltage. So at a time we have two phasors. In case of star and delta, at a time we have two phasors with respect to currents in star, with respect to voltage in delta. You have two phasors at a time. Okay. So in order to avoid confusion, here I am providing the phase and phase which is equals to line in case of delta. Then after 120 degrees of VR, we are having what? Vy. Like that, after 120 degrees of this Vy, we are having Vb. Clear? This is little bit long. Now it's okay. Like that, after 120 degrees of Vry, we are having what? V by B. Like that, we are having VBR completed. Then see the load. Load is what? Lagging load. Therefore, phase current lags phase voltage by phi. Therefore, lagging means what? Like that, you have to write. This is what? IR. This is what? IY. So first VR, IR, VY, IY, VB, IB. So over 360 degrees, always this phase vector should rotate by 360 degrees. Like that, the phase current should follows the phase voltage lagging by 30 degrees over 360 degrees. That is the meaning, right? Next, like that, here also the load is what? Lagging load. Then here the phase current is what? Representation is what? IRY, right? IRY lags phase voltage by phi. This is what? IYB. Then this is what? IBR. That's it. This is what? Phase current, which is equals to what? Line current only in case of star. This is what? IRY, only phase current. See, we are having phase voltage, line current, phase current. In this case of delta, we are having phase voltage vector, line voltage vector. Like that, phase current vector also. Only we are pending with what? In case of delta connection, we are pending with line current. In case of star connection, we are pending with what? Line voltage. That's it. Then to get line voltage in case of star connection, see, VRY is nothing but what? Vector difference of VR and VY. In case of delta connection, to get line current, IRY minus IBR. So we have to get negative projections of VR, VY, VB. Like that, negative projections of minus IBR, IRY, IYB. Okay. So this is what? Negative projection of VR. This is what? Minus VY. Like that, this is what? Minus VB. Completed. Like that, in case of delta also, IR is what? IRY minus IBR, right? Therefore, this is minus IBR. this is IYB and negative IRY. This is negative IRY. Clear? Then first we have to get the line voltage in case of star connection. To get VRY, VR minus VY, right? Therefore, VR minus VY, which is parallel to VR, which is parallel to minus VY, completed like that. To get VYB, like this. To get VBR, parallel to VB, resultant of this two vectors, that is the meaning. To get line voltage, we have to get the resultant between two phase voltages, like that. In this case also, to get IRY minus IBR, right? This is minus IBR, right? Therefore, parallel to IRY, this is what, like this. Next, between these two, like this, between these two, completed. Now we have to get the line voltages. This is what VRY, which is present between VR and VY. This is what line. See, we have line voltage, phase current, line current, completed. This is what VYB. If you have one vector, obviously you will get remaining two vectors. Just you have displaced with what? 120 degrees. That's it. If you consider any vector, line vector or phase vector or any vector, the remaining two vectors are displaced by 120 degrees because the load is balanced load. We are considering the three-phase balanced load, right? Like that, in this case also, between IRY and minus IBR, this is minus IBR, right? We are having what? This is IR. Like that, between IYB and minus IRY, we have IY. We have over the phasor diagram with respect to lagging load is over. This is line voltage, so line current. So we have line current, phase voltage, line voltage. In this case also we are having four quantities completed. Then we have to mention the angles. This is very most important. Here the load is what? Lagging load. Obviously the phase current lags phase voltage by 5. Here also 5. Okay. Now what is the angle between line voltage and phase voltage? It is always 30 degrees, right? Line voltage leads phase voltage by 30 degrees in case of star connection. Like that, line current lags phase current by 30 degrees in case of delta connection. Okay, this is 30 degrees. Like that, between this 30 degrees. Okay, degrees. Now what is the phase angle between line voltage and line current? That is 30 from here to here, 30 from here to here, 5. So the phase angle between line voltage and line current is what? 30 plus 5. These are the very important observations. This is what? 30 plus 5. If it is lagging load, that is 30 plus 5. Like that, what is the phase angle between these two? Line voltage and line current. Obviously 30 plus 5. That's it. This is about lagging load. First you have to draw phase voltage, then see the load. The load is what? Lagging load. Then phase current lags phase voltage by 5. Okay, that's why we have this. Then to get line voltage, which is the vector difference of two phase voltages, in this case of delta connection, to get line current, which is the vector difference of two phase currents. That's it. Next we have to draw with respect to UPF load. You are having clear cut knowledge about lagging load, therefore the remaining two load analysis is very easy. That is, what is the common point here? I phase is in phase with what? V phase, right? Phase current is in phase with V phase, that is phi is equals to 0 degrees. Phi is equals to 0 degrees. Yeah, first we have to draw phase voltages. VR, Vy, this is what? Vb. Okay. In this case also, the phase voltage is what? VR by Vyb. This is Vbr. That's it. Okay. Then see the load. Load is what? UPF load. Always you have to draw the phase current which is in phase with phase voltage. Which is in phase with phase voltage. That is, this is IR. This is what? IY. This is IB, right? Here also this is IRY, this is IYB, this is what? IBR. Completed. Okay. Then to get line voltage, VR minus Vy, right? It is. Okay, these are negative projections of this currents. Then like that, between these two, so like that in this case also. Next one is what? Yeah, between these two we have to get line voltage in case of star connection. This is VRY, VYB, VBR. Completed. This is what? IR, IY, IB. That's it. This is VYB. That's it. This is the phasor diagram in case of star connection, in case of delta connection. Then what is the phase angles? Phi is equals to 0, we all know that, but at any case the angle between line voltage and phase voltage is 30 degrees, and the angle between line voltage and line current is 30 degrees, because phi is equal to 0, 30 plus phi, 30 plus 0, 30 degrees. This is, at any case this is 30 degrees, and phi is equals to 0. This is very, very important. Okay, this is about UPF load. Next, capacitive load. Okay, capacitive that is what leading load. Leading load means what? Leads ahead P phase by phi, right? Then this is what? VR, this is Vy, this is what? Vb. Like that, in this case we are having VR by Vyb, this is what? Vbr. Completed. Phase quantity is completed. Then see the load. Load is what? Pure capacitive load. Always current leads, right? This is IR, this is IY, this is IR VR, IY Vy, this is IB. Completed. In this case also IRY, IYB, and that's it. Then to get VR by VR minus VB, right? VR minus VB. So we will get okay. In this also we are having negative projections like this. Okay, then it is also different color. Okay, like this. This is minus Vy, this is VR. Okay, like that. Test IY. This is IY, right? Next, between these two, just IRY. IB. Okay, between these two, like this we are having, right? Then the result of this is VR by, this is Vyb, this is what? VBR. Okay, then in this case what is the result between positive VRY and negative IBR in this, right? Sorry, positive IRY, negative IBR, right? In this case what we are having, like that, positive IYB, negative, clear. Next, in this case also, sorry, Like this we have to get. Don't scale it because this is a pentab. Okay. This is VBR. Okay, now we have to write this is what IR, IY, IB. Then what is the phase angle between different quantities? Always the phase angle between phase voltage and phase current is phi. Here also phase voltage is VRY and the phase current is what? Phi. Clear? Which is leads. Then what is the phase angle between line voltage and phase voltage in case of star connection? Always 30 degrees, right? Means this is always 30 degrees only. So to get the phase angle between VRY and IR, that is line voltage and line current, which is what? 30 minus 5. Clear? Like that, in this case also, what is the phase angle between line current? This is line current, right? Line current versus phase current. So light. Yeah, between IRY and VRY is phi. Like that, between this phase current and line current, what is the angle? 30 degrees, right? This is 30 degrees. 30 degrees. Okay. Then what is the phase angle of this? This is, what is the phase angle? This is phi. From here to here phi. From IRY to IR 30 degrees. Then what is the phase angle between VRY and IR? Which is equals to what? 30 degrees minus phi. Okay. In case of lagging load, it is 30 plus phi. In case of UPF load, it is 30 degrees. In case of capacitive load, it is 30 minus phi. Between IRY and IR, between VRY and IR. Okay. Let us see. This is VRY. That's it. Okay. This is about capacitive load, UPF load, inductive load. See, with respect to lagging load, here I am explaining once again. See, first you have to draw phase voltage in case of star as well as delta. Then after that you have to check the load. The load is what? Here lagging load. Therefore phase current lags phase voltage by phi. Therefore phase current is what? IR only. In case of star, IR is the phase current. In case of delta, IRY is nothing but phase current. Just you have to draw this phase current just by lagging V phase by phi. The angle between IR and VR is phi. Like that, the angle between IRY and VRY is nothing but phi. Clear? Then we all know that in case of star connection, phase current is equals to line current. In case of delta connection, phase voltage which is equals to line voltage. So we have phase voltage, line current, phase current in case of star connection. Like that, we have phase voltage, line voltage, phase current in case of delta load. Obviously we are going to get remaining one quantity, that is in case of star connection we have to get line voltage. Like that, in case of delta connection we have to get line current. That's it. For that, to get line voltage in case of star connection, vector difference of VR and VY. That's it. In case of delta connection, it is nothing but vector difference of phase currents. So after getting that, we have to locate the angles between different quantities. We all know that the angle between two phase quantities phi. Clear? The angle between line voltage and phase voltage is 30 degrees. That too, line voltage leads phase voltage by 30 degrees. In case of delta connection, the angle between phase current and line current is 30 degrees always. Then very most important observation, the angle between line voltage and line current is what? That is from here to here is what? 30 plus 5. That is from here to here 30, here to here 5. Therefore, the angle between line to voltage to line current is what? 30 plus 5. Like that, in this case also, the angle between line voltage and line current is what? 30 plus 5 in case of lagging. In case of leading, it is 30 minus 5. Just you have to observe in case of phasor representation. But in case of UPF, that is only 30 degrees because phi is equals to 0. So this is the analysis of lagging load, UPF load and leading load. Just you have to draw with pen in the empty paper by closing this analysis. Then only you will have better idea about the phasor diagrams. Okay.